In this video, we will see code implementation. Now let's quickly do the code implementation part. So we have n in the edges, right? So first I will create a visited array. So let's visited, let's suppose viz is equals to new array of size n, okay? And I will fill it with basically false in the starting. Once I have done this, what I will do, I will simply call the adjacent is equals to new array, and I will create with the n size, and I will fill it with the basically I will create a 2D array of it. So I will say dot map of, okay, that's a simple, basically in each this I will pass an empty array. Okay, now what I will do, I need to create an adjacency list. So for, okay, const or let, you can use anything. I am taking u and w as edges of my edges, basically edges point edges, okay, and if the adjacency of u, what I will do, I will push v not v w. So I will put w, same copy, paste it here. In the w I will push u, right? So in the w I will push, done. So here you can see this will create your adjacency list. Once this is done, what you will do, you will simply take few of the variables. Let count equals to 0. Suppose you are creating one resultant number of components, so I'm telling you about that one also. So we will requiring two arrays for it. Okay, now what I will do, I will simply run a loop that will start from 0, I less than, and I plus plus. Okay, and I will simply say if I have not visited I, okay, what I will do, I will simply say now call my DFS function. So I will simply say res is equals to empty. Basically before calling I am simply making it empty. Now DFS of I, then passing my visited and passing my res. Basically it will take the how many number of components I'm using. Once I will come from here, I will update the count plus plus, okay, and I will simply push my answer, that is the res, triple dot res, the number of components. Okay, and after this what we can do, we can return count. Okay, you can return the two things, that is one count, okay, count equals to count, and you can put your right number of components. So suppose answer equals to answer, like this one. Okay, now what we left with the function DFS. So let's quickly create a DFS function where we have passing the I, visited array, and the res resultant. Okay, if suppose I have visited it, I will simply mark it as true that I have visited it. Once I have visited, I will push into my res array, push of I. Now what I will do, I will simply iterate through this, basically adjacency I, whatever there are neighbors, right? Whatever the neighbors of this array. Okay, so how can I call it? There are different methods. I'm using the simple one, okay, array, so that it will be clear to other. There is one standard method. I want you to follow this once you are clear with this one. That's the first question. That's why I'm using. So that's a basic meaning. J is starting from 0. J is less than array dot length. So here you can see the array I have created from the adjacency of I. Okay, so array dot length and length and j plus plus. Okay, and this will be my for loop of a DFS function call. And same thing I will do where I am calling the here, right? If visited, then I will simply call the DFS function. So if visited, then I will call the DFS function. Now there is no to TRS because it will simply reverts to its adjacent. Okay, and visited of array G, because here array G will be the element, right? Visited of I, basically what is I? That is array G, the neighbor of it. Okay, and I will call it here also, it will come to array G, not I. Okay, so if visited of array G, then call DFS of array G, basically its neighbor node. Okay, once you have called it, you are done with it, you will simply return. Okay, now see, the same thing you can do simply. Instead of J equals to 0, you can simply say neighbor of, let neighbor, basically because we are calling the neighbor of adjacency of I. Okay. So adjacency I, whatever the neighbor is, you will get the complete neighbor wise array, or you can simply say ARR. Okay. So you will get each element of this array, right? This is also you can do. That's a one standard method. So yeah, this will be the code implementation of this problem. I hope you are clear with it. So in the next video, we will quickly understand what is the basically maybe like I have missed some bracket here and there. So this for loop done, for loop here it's done, if condition is done, and here if okay, that's a if condition, for loop is not done. So this will be a for loop, this will be a function, yes, and this will be a this is done. Now once this is done, right, we will see about the code dryer. Okay, so I will give you a quick walkthrough of it. I have already discussed how basically it will work, but I will give you a quick walkthrough of it, basically how we are calling this and how everything is working here. So we will see a quick code dryer in the next video. Okay, so see you in the next video. If you want a quick code dryer, otherwise you can start implementing from here itself. Okay, see you in the next video.